How's it going, you guys? It's another day and welcome back to Asking the Right Question. Today we're going to be covering the following: variables, their names, their types, and their values. Printing variables. A variable is basically something that says that this word really represents something else. So in English, for example, I could say it's blue, and you wouldn't have to know what I'm talking about because it refers to the curtain. Or I could say it's Hawaiian, where again, it refers to the shirt. So just like in English, where I can use a word, it, to represent almost anything or a variety of things, in programming, we often use variables to really let the computer know what we mean. A variable is comprised of three different things: a type, a name, and a value. For example, let's say if we have x is equal to 6. The name of the variable is x. The type of the variable is a number. The value of the variable is 6. If I wanted to have a new variable, y equal to 12, y is the new name of this variable. Again, the type is a number, and the value of that variable is 12. C++ really won't care about what you name your variable. So your variables can't really be named numbers, at least at the beginning. But as long as it starts off with a letter, you can pretty much go off the roads on that. You can't say 7 equals 6 because that would be very confusing and the computer wouldn't know how to interpret that. So you could have, say, x7 equals 6. This might be confusing, but because the name is x7, the type is a number, and the value is 6, it's all good. Why are variables useful? Let's say one car costs me $8,768. So the cost of 10 cars could be written as 10 times x. Now, let's say someone went back and told me, hey, the cost of one car is actually not 876, but 18,768. I can easily update one variable and still maintain the correct answer in the other variable. A very important thing about variables is exactly how you name them. As you can see, if you were to look at this without my verbal explanation, this would be super confusing to understand. So we're going to go ahead and try a different naming convention. Tell me what you think of this. Easier to understand? While this chunk of code and this chunk of code are doing the same thing, this latter part is significantly easier to understand. One pro tip is, if you have the time, and you always will, take that extra minute or two to think about what does this variable represent and name it as precisely as possible. While C++ is going to be very lenient on your variable names, that doesn't mean you have to be. You should be as strict on yourself about the naming of your variables, because when it comes to it, you're going to have tons of variables in your code. And just having to keep track of everything in your head is going to become burdensome. The one thing that we really haven't talked about here is, why do I have underscores in my names? These underscores really represent spaces. You can't have a variable name with spaces in your code. If you were to put a space, your computer wouldn't know if it should interpret that as two variables or one variable with a space. So oftentimes, if I use multiple words, I prefer to use an underscore in my naming convention. As you talk to more developers, you'll find that there are many different types of naming conventions. For example, all of these naming conventions are acceptable. What's most important is that you remain consistent with your naming conventions. If you'd like to stick with mine, then I would advise you to use this naming convention. But again, there's no incorrect answer here. The only incorrect thing would be to scatter different naming conventions all throughout your code. While we've described variables as a whole, the one thing we haven't really described is, how do variables work specifically in C++? We'll be using a format that looks like this, where we'll write the type of the variable first, then we'll type in the name of the variable, then we'll say what is the value of the variable, And of course, we'll always end it with a semicolon. So we already discussed name, and we kind of know what values can be. The one part we haven't discussed yet is what is the type. So there are a couple of key different types that you can use in C++, and they all have their pros and cons. Some of the types are going to be an int, which stands for integer, a float, which stands for a floating point number, and a character. Now, there are many more types in C++. These are the ones we're going to use in the beginning. An int or an integer is basically a whole number. A floating point number is a decimal number, and a character is kind of like a letter. So let's go back to our REPL. And again, this is our code from last time, but let's try and declare some variables. So we have an int as our type, a number as our variable name, and we set the value to 12. And let's try and run the code. It runs just fine. Now, if you'll notice, we didn't see anything related to number print out. That's because we never told our program that we actually want to print out our variable, which is named number. If we did want to print it out, then all we have to do, just like last time, is call std cout number. Now, last time we put things in quotes, so let's try doing that first. Let's go ahead and run. Interesting. What we actually ended up printing out was the word number. That's because whenever we put stuff in quotes, C++ is going to print it out exactly as I told it to. If we actually wanted to refer to the variable number, then we simply take out the quotes and go ahead and try and run this. We get the value of 12. Awesome. Let's try and change this a little bit. Let's make this 1200. Just like we expect, whenever we tell it to print out the variable number, notice this is a variable because it's not in quotes, it will print out the value of this variable, which is, in this case, 1200. Now let's go on to floating point numbers. What's different about float? Float is basically going to be another number, and we could make this equal to 1200. So let's try and print out float. So now that we've written our float number, let's go ahead and print it out. Std cout another number. And you'll notice autocomplete, which I can use using the tab button, makes my life easier. Interesting, I got two 1200s, which looks right, but because they're right next to each other, it's really, really hard for me to understand. I want to put a space in between both of them. So I put a space inside of quotes. And what console output will do is print it out exactly how I told it to. And voila, there you have it. I got two numbers, 1200 and 1200. But let's say this is actually 1200.5. Because floating points should be able to represent decimal numbers. Let's see if we would get what we would expect. And once again, we can see it's 1200.5 for another number right over here. Because the first thing this program does is it first prints out number, which as we remember is 1200. It then prints out a space right over here. And lastly, it will print out the value of another number, which is a floating point number, which has the value of 1200.5. Now, some of you may be asking, what if I made number 1200.5? Let's go ahead and run it anyway and see what happens. Interestingly, you may have noticed that we got something that looks like an error, but really this is a warning. Now, often if your code is getting warnings, you're probably doing something funky. But even though it gave us a warning, it still did run our code. But you'll notice that this is exactly the same as last time. That's because, like I said before, integers are just whole numbers. But unlike math, they don't do any rounding. They just take the non-decimal part of the value, and that is it. So 1200.5 becomes 1200. 1200.99999 will hence become 1200. That's because remember, integers will just chop everything off on the decimal side and only preserve the actual integer value or the whole part of that number. And lastly, let's go ahead and talk about characters. Characters are special. Just like whenever we use cout, we have to put stuff in quotes if we want to do something. A character has to be put in quotes as well. If it's one button on your keyboard, it's a character in C++. Even the spaces and the tab and the backspace and enter keys, we'll go into the whole list of letters in a future lesson. But for now, most of the common things you're going to want to type are going to be letters. Because a character represents just one letter, we indicate it with just a single quote. This makes it both clear to the computer and to anyone reading it that we mean just one letter. Now let's say you wanted to have multiple letters. You wanted to have A, B, C. Char, or your character variable, cannot be more than one letter. It's going to give you an error. If you ever try and do this, luckily the computer will catch it for you and you don't have to really remember it. You just have to remember why you can't do it. That's because a character simply represents a singular character, not a bunch of characters. So we're going to go ahead and make our character C, and just like anything else, we can kind of just go std_cout, and let's put in another space in the middle, and std_cout our one character variable, and let's print it out. And as we expect, we got the C at the very end of our code. We got a new space that we added in, and another C. What are some other examples of characters? The @ symbol is a character. The space is a character. And of course, if you print out a space, you'll be a little confused, but if you highlight it, you'll notice that there's one extra space at the very end. Well, that's it. That's literally as easy as it sounds. To make a variable, all you have to do is first declare the type of it, then give it a name, then put an equal sign, and assign the value. All I'm doing when I'm assigning values to variables is I'm taking whatever's on the left-hand side of the equal sign and matching it with whatever's on the right-hand side. So often I'll denote this as LHS and RHS. And what all these stand for is right-hand side and left-hand side. Anytime I'm going to do this, I'm going to take whatever's on the right-hand side and set it as the value of the left-hand side. Let's write a slightly more complicated example in our code. The cost of one car is $1,200. Let's say the cost of another car, so we can call this car 1 cost, and let's say the cost of another car 2 cost, is $9,878. So what is my total cost of both cars? So I can say the total cost is equal to car 1 cost plus car 2 cost. And of course, if I were to std_cout total cost semicolon, we will see that the total cost of the car is going to be $11,078. I could make this slightly better for the user by adding a nice little sentence before it by doing std_cout total cost is, and put a colon, put a space, and then even put a $sign here. And now you'll notice I got a really nice fancy statement out here that looks kind of just like a human would write it. That's because all I did was say that this is going to be printed out to the console, and then after I print this out, I'll print out the total cost variable. So I printed out the total cost is with a space, added the $sign, so that is this part right over here, and then secondarily printed out the total cost variable right after. Now, once I've done this, what happens if I wanted to update the cost of the car? So car 1 is going to get a new engine, for example. And the value of the engine upgrade is going to really amp up our car cost. It's going to double our car's value. So now the car 1 cost should really be its original cost plus the engine upgrade value. Now, if you're a little confused by what I wrote here, that's okay. This is often one of the most confusing parts of programming when people are first starting out. Let's jump back to the iPad for a little bit. If I wrote something like this in math, my teachers would fail me. If I wrote, let's say, x is equal to 10, and then x equals x plus 1, there's no way this will ever be true. And you'd be right. This statement is false in math. But in programming, remember the equal sign represents assignment, or setting the value on the right-hand side over onto the left-hand side. So what I'm really doing here is I'm going ahead and taking the right-hand side and setting the value on the left-hand side. What I like to do to avoid any confusion is if I see an equal sign, I just ignore what's on the left-hand side for now, and then I go ahead and think purely about the right-hand side. So in this case, where x equals 10, what is x plus 1 going to equal? X plus 1 is going to equal 11. Now all I'm really writing over here is x equals 11. So I have now written an update to my variable x, my variable named x, that its new value is now actually 11 instead of 10. Again, let me repeat this because this is a little tricky. So let's say we have a variable x equals 10, and then I said x is equal to x plus 20. So the first thing we're going to do is we're going to evaluate just the right-hand side, ignoring everything that's on the left-hand side. We know that x is equal to 10, so x plus 20 must equal 30. And now we get the statement x is equal to 30. So from here onwards, for the rest of our code, x is going to equal 30, even though until we did this line, x was equal to 10. From now onwards, x is going to be 30. And I'll demonstrate this in an example for you. We're going to print out the car 1 cost. And once again, just like before, we'll leave a $sign. Let's add a new line here. And then let's mention the engine upgrade cost. Std engine upgrade is worth $sign, semicolon, std the variable name engine upgrade value, std std for the new line. And then because we want to see the new car cost, it's kind of exactly what we already did over here, so we can just copy and paste our code over here. Just to really make sure we're not really confused, we'll put the new car 1 cost is so many dollars, and of course our car 1 variable. So let's go ahead and see what's going on. So our car 1 at the beginning of this code was worth $1,200. We know that the engine upgrade was worth $1,200, so the new car 1 cost was actually $2,400. So if you'll notice, the same variable, when I printed it out twice, actually printed it out 2 different values. The first time it printed out 1,200, and the second time it printed out 2,400. That's because in between printing them out, I actually updated or modified the value of the car 1 variable by reassigning to it a new value. And remember, all I did was assign a variable a value, just like I did exactly on line 4. The only difference is on line 4, I assigned it a value I hard-coded, or I typed in directly. And on line 14, I assigned it a value that I gave it by some expression that I described later on the right-hand side of the equal sign. Now, one of the things I'm going to teach you is something that's going to save you tons of time. When you use std_cout, you don't actually have to write everything on a new line. An alternative to writing everything on a new line is you could just use one std_cout and say my new car1 cost is $. But instead of putting the semicolon here, I can indicate I want to keep on printing stuff out by adding more arrows. And then put in the car1 cost variable. And because I still want to print out more stuff, the new line at the very end, I can do std and L semicolon. Let's go ahead and see what's going on over here. And you'll notice I got the same sentence coming out twice. That's because this and this are exactly identical. This is just shorthand and often easier to read. But if you're still more comfortable with having every line just print out one thing at a time, there's no reason to rush towards this. But for my case, I'm going to go ahead and kind of leave it like this, so it's easier to understand and you'll have an example for yourself. Well, that's it, guys. You've got a solid taste on variables today. And after this, I really hope you go ahead and do some of the exercises that we've designed for you. The exercises are really designed for you to get some solid practice in. This week's exercises are going to involve reading some word problems, getting used to naming, picking great names for variables, thinking about the types of variables, and even writing some code on your own for the first time. So head on over to the GitHub and don't forget to join the Slack channel. All right, see you around. Bye.